So if we're going to build telemetry systems, we need to start developing concepts and methods to address these practical issues that I've brought up. Like I said, you're concerned about a lot more than just what the value is. All that other information about what took the measurement, whether the value is reasonable, whether any issues were detected in the measurement of that value, all that stuff becomes important to me as well. So let's talk a little bit about some of the concepts here. Alright, so to start out with, how do I identify these measurements? So each one of the, I talked about, I might have, I might take thousands of different voltage readings in my electric grid, and how do I catalog these things, or how do I identify them? Well, what we do is we give each one of these measurements a tag name. So you refer to these things as tags. And you'll often, when you build a control system or you talk about a control system, one of the things that you'll always talk about is how many tags are in the system. So you might build a system that has 20,000 tags or 100,000 tags or 1,000,000 tags. But when you're talking about a tag, you're talking about a value, a specific value that you're measuring. What is this value? Well, there's different types of tags, right? Some of them are floating point numbers, meaning that it's a real number, like a value that you're reading from an instrument. So floating point value would be, example would be 119.4 volts. But you also might have tags that are integers. So maybe you've got a piece of equipment, maybe it's a breaker, an electric breaker, and you want to count how many times that breaker's been opened. And so you might have an integer tag that's the number of times that breaker's been opened. You might also have a digital tag, so whether that breaker is opened or closed, or whether a motor is on or off, those would represent digital tags. So there's different types of tags. They don't all hold the same types of values. Typically, when you create a tag, the tag is created to hold a specific type of value. So you'll create a floating point tag to hold a voltage, and it'll always only hold voltages. Or if it's a count, it'll always be an integer. Or if it's a digital tag, it'll always be a digital tag. So you might also have a string tag. So maybe somewhere in the system, you're going to have somebody put some sort of a comment about something, or there's a notes field, and so you might have a tag that's a string. So over time there will be different strings in that tag. So, but this concept of a tag is central to pretty much any kind of telemetry system or control system, or as we talk about later, data historians. They all concern themselves with tags, and a tag always refers to just a single value that you're measuring in that system. So, when I get a value, we talked about a floating point value, a voltage of 119.4. This tag is going to have certain metadata that's associated with it. This metadata typically doesn't change a whole lot, but when you define the tag, you define these other values with it, and so. Some of the things that I need to know about the tag is maybe what's the minimum possible value, what's the maximum possible value, what are the engineering units of that value. For this example, it keeps being volts. And also, a lot of times the tag will have a descriptor that's available with it. So a tag name might be something, and let me just do a little example here. So a lot of times, like I do a lot of work in power plants. So let's just do a power plant example here. A tag name might be something like U1 colon B, 1, 2, 3, 4 dot PV or something like that. So you'll have a tag name. Typically they're segmented, and there's some sort of a convention that you're using for the tag. We won't talk about all the different conventions you could use, but this would be, you know, like a unit 1 boiler tag 1234 process variable. So these tags tend to be, you know, if you know what you're looking for in the tag, you can look at the tag and you know exactly what it is, or if you're familiar with the system, you know what it is. But a lot of times it's helpful to have a plain English descriptor available with it as well. So the example I have here is transformer 1 output voltage. So you know, the descriptor is just a plain English way of looking it up and describing what it is. So these are just some of the metadata values. There's certainly more that you could put in there. You know, in the electric grid, you might want to put something like a geographic location. So you might have a longitude and a latitude associated with it to tell you exactly where it is, or a street address or something like that. So all these things they're metadata about that value. But when you build a system, you have to stop and think about the kind of information about the tags that you're going to want to have. So when was it taken? Now here's a thing, like I've mentioned this. So you go and you look on a screen and it says the value is 120 volts. Well, that value, the measurement that you're taking, may have been taken 200 miles from the control room you're sitting at, and so there's a certain delay. Depending on the equipment that's taken, maybe it could be taking that measurement every 250 milliseconds. It could be taking it every 15 seconds. It could be taking it every 10 minutes. So one of the values, or one of the things that's always valuable to know about the value that you're looking at, is the timestamp, or when it was taken. So each value as it's taken is given a timestamp to indicate when it was taken, and this allows two values from different parts of the grid to be correlated. So, you know, obviously, again, if I'm looking at the screen and I'm looking at two different voltages and they look like they're the same, and then I realize the readings were taken 10 minutes apart, I know that what might be happening in the real world may not accurately reflect what I show on my screen. Now, as we take these values, so let's say we're taking a value, I go and I take a reading, and every second I'm reading this voltage value, and I'm storing this. So I have a series of information. I have a number of readings. Each one has a timestamp. Each one has a value. And so as I store these, this type of data is called time series data. Okay, now you're going to remember this. You're going to know all about time series data by the end of this course. But this right here, time series data is a specific kind of data, and dealing with it and storing it and everything else becomes kind of an area of study in and unto itself. This data becomes very valuable for analyzing the operation of the system. So if I'm in the control room, and let's say I've got a little trend on my screen, right? So I'm looking, and so I've got, you know, this is now right here, and maybe this is now minus 10 minutes, okay? And I see the values done something like this. You know, that means something different to me than if the value had done something like this. So, you know, dealing with time series data, storing time series data, displaying time series data is a very valuable thing for us. Let's say there was a problem, and I go back and I look at my trend and I say, oh yeah, you know, there was this upset. This happened right here. Well, that's valuable in helping me troubleshoot what's going on. And maybe if I can display this value and 5 or 6 other values from the electric grid, maybe that helps me to figure out what's going on. Maybe I could have, you know, a trend here that shows a breaker that went from closed to open, and, you know, after that happened, I had some sort of disturbance or something like that. So it becomes valuable for, you know, troubleshooting what's going on, and also historically, if we've stored this data, then we've got this history of the system, and we can do analysis of the system. We can troubleshoot ongoing problems. Maybe, you know, maybe it's a short-term problem and it happens, and we can see what happened and figure it out. Maybe other times there's something bad happening in the grid, and we're not able to figure out what it is, and we have to go back and collect all this historical information and analyze it and trend it and try and see if we can figure out what's going on. So this study right here, this study of time series data, is really it's a concept we're going to spend a lot of time exploring. Okay, so is the information I'm receiving reliable? So we're not only concerned about the reading, but when it was taken, and we're concerned about the quality of the information. So we may have taken some sort of measurement. Maybe I go to the screen and it says 200 volts, and I know that should really be somewhere between 0 and 120 volts. So that's where the metadata about the reading or this tag becomes valuable. If I go and I look at it and it says the range is 0 to 120 volts, and I'm for some reason getting back a reading of 200, then I know there's a problem. And that problem could have been anywhere along the line. The piece of equipment making the measurement could be wrong, or the data could have been garbled, or something might have happened as it was being communicated back to me, or maybe somebody made a configuration error and they put the wrong information in the wrong tag. All kinds of stuff like that could have happened. Also, most of these systems will have some sort of a tag quality associated with each reading, and so if the system knows that there was some sort of problem along the way, it'll flag that data as questionable.